You may have heard of robots.txt before. It's essentially a file at the root of most domains like wikipedia/robots.txt. This gives instructions to any passing bots about what they should and shouldn't scrape. And the syntax of this file is determined by something called the Robots Exclusion Standard or the Robots Exclusion Protocol. The cool thing is, you don't need to really worry about any of that in order for your scrapers to follow robots.txt. Check out settings.py in the news article scraper I used as a solution for the challenge in Chapter 2. You have the obey robots.txt rules, and it's set to true here. So ScrapeEye will automatically go to the robots.txt for any domains you give it, check out what it can and can't scrape and then follow the rules there. And listen, obviously, if a site's robots.txt is a big problem for your scraper, you can always set robots.txt obey to, false, I guess, but please don't do this for Wikipedia. As I've talked about before, they have a fantastic API out there, and there's no reason to disobey their robots.txt. It's really very generous, all things considered. Other sites, I guess, go nuts, but Wikipedia is nice, so let's be nice to it. Moving on, I don't want you to think that robots.txt is just a buzzkill for scrapers. Speaks in foreign, there is a wealth of useful information that can be found in these files. In fact, when you have a large crawling project, investigating robots.txt can be a good first step. So check out cnn.com robots.txt file for example. Like many robots.txt files, it lists some sitemaps up here. See those, and what these sitemaps are XML files designed to be read by search engine scrapers. So that search engines don't miss any pages or they can view the latest updates to pages. And if we follow this a bit, we can see the sitemaps index, and we can actually choose any month we want, and check that out. It looks like the formatter is having a hard time with this one, but we can see just like a list of all the recent news articles. A lot of recent news articles, a lot of news lately that CNN's published. And this looks like October 2020. So take a look again at this CNN scraper I made for the Chapter 2 challenge. It goes to the start URL I give it, looks for internal links to articles, looks for internal links to more articles from those, and kind of goes on this recursive random walk throughout the website. The site map, by contrast, is an orderly listing, so we can stop our scraper halfway through, know exactly where it left off, make sure we're not missing anything. Finding a site map is an amazing thing for web scrapers, and ScrapeEye can actually deal with them out of the box using the sitemap spider. So the sitemap spider, we want to import that from ScrapeEye.spiders. Perfect. And it's pretty easy to change this spider here into a sitemap spider. Obviously we get rid of start URLs. We don't need that anymore. We don't even need rules. It's literally just going to take the sitemap and use that. So we do need to provide it sitemap URLs. We can give it a list, but here we'll just do them one. So October 2020. We can use the same parsing function even. Alright. I think that's it. So, let's run it. Typing, perfect. Now, wow. Now we have a spider that's crawling linearly through an organized list of articles provided by CNN itself. So, thank you robot overloads. What if a client comes to you with a web scraping project and says, I want a database of all CNN articles from the last 10 years, and I need to be reasonably certain that this is a complete collection, gathered in an ordered and systematic way. So what do? Remember, a ScrapeEye crawler, like the kind we worked with in Chapter 2, might reach all the pages eventually, but it might not, due to the random path it takes throughout the website. It's hard to crawl in an orderly way. So this type of solution isn't going to meet your client's needs. But is there a way where you can take 5 minutes, do a little exploration, and go back to the client and say, 10 years of articles, I can give you 20. Or maybe it's, sorry, I can only do the last 8 years. Is there a way you can estimate how many articles are available quickly, which can translate into how long it'll take to scrape? So take a few minutes, explore cnn.com. Think about how you'd build the scraper. Maybe put together some highlights for the client. Think about how you'd write an email back to them, for example, and then head over to the next section where we talk about this problem. So you hopefully picked up on the hint in the challenge setup. The client wants some confirmation that we scraped all of the article data in an orderly way. So this means that you want to look for some sort of a complete comprehensive article listing to take advantage of, like a site map, right? So, remember robot, mumbling, texts is the best place to find these site maps, and often the place you want to start for any scraping project. From there, we find the site map index, but all of these site maps off of this are kind of out of order and there's some repetitions, and it's not super clear what's going on here. One thing that should be obvious though, is that if you take the article site map, there we go. This is the year and this is the month. So this is October, 2020. And what we can do is actually just change the year in here. So we can go back to 2015. There we go. Articles from 2015, and we can do some spot checks kind of going back. So 2010, do we have that? Ooh, number 2010. Do we have 2011? Yeah, great, there we go. So do we have? There. Alright, we have that. Do we have December, 2010? Great. We can sort of narrow down on how many years of data we have. So it looks like there's nothing online quite as far back as a client wants, not quite 10 years, but pretty close. We can tell the client we can get them data from January 2011 to the present. And let's say we really want to blow this client away, tell them exactly how many articles we can anticipate getting without actually needing to scrape all of the articles first. So we can build a quick scraper that doesn't scrape the articles themselves, but simply scrapes the sitemap files. We're going to do this with a crawler and a generated list of URLs, similar to what we did with form scraping. So we have this generate start URLs function here, and you can actually think about these sitemaps as kind of an API. Just stick a month and a year into the URL and it'll give you back a list of articles for that month and year. The rest of the crawler is fairly straightforward. The only thing we need to return is the current URL, right? And the count. And there's actually no need to use XPath or parse it as XML or do anything fancy here. You can just literally count the number of times the URL tag comes up. So, sometimes the dumb ways are the best, right? And we can run this and we can export the results to CSV file. This is going to take a little bit, so I did it beforehand. Alright, so here we go. Here's the counts file that gets generated. And again, sometimes the dumb ways are the best. This is just a little quick one-off thing for a client, you know, no harm in opening it in Excel. Obviously, there are some slick programmy ways to do this, but sometimes you just want to open an Excel, sum it up, and then we get 253,589 news articles in the last, almost 10 years. Note that the dates for the future, I think there are a few of those. They don't have any articles associated with them, so that's kind of fun. But yeah, all the data looks really good. So far all the data we've scraped has been public. You don't need a user account or any particular credentials. You don't even need to pretend that you're not a bot. The websites are really just happy to accept anyone, right? But in this chapter, we're going to start looking at becoming something we're not. So whether that's a credentialed human user of a website, an actual web browser executing code, or someone sitting in front of a computer screen pushing buttons. And in this particular section, we're looking at logins. So as usual, our web scraping adventures are going to begin, not with ScrapeI code but with just looking at the website. So that's really important. We're going to look at the website, we're going to see what's going on with it. And that website is going to be a login page, pythonscraping.com/linkedin/cookies/log-in.html. And if you look at this login, there are some little hints about what you can use as credentials. So my username is going to be Ryan and my password they helpfully suggest, let's try password. Okay, and let's open up the network tab to see what calls are being made when we hit the login button. You can see we've made a post request to welcome.php here and you can see that we've sent some form data along with it. There's our username and our password. And if you remember, we did the section on submitting forms, and you might be tempted to replicate this with your ScrapePie scraper, but you're not actually going to do anything just by replicating this. So the act of making the request to log in, making this HTTP request, isn't actually the important part. You can see that we're still logged in when we click from page to page on the site, and the important part is actually the headers that get set, the cookie that gets set. And if you look at the cookie that we're sending whenever we make a request to this website now, the username is Ryan and you have logged in equals 1. Now in reality you're probably, hopefully not going to see a cookie like logged in equals 1 on a website, and in reality, it's going to be some sort of long authentication token with a timeout, and it gets renewed by the server and all that. But the principle is the same. You want to make sure that whatever cookies you have while authenticated on the website are being copied and sent by your Python web scraper while it's making requests. So let's look at how to do that. I have a new project called Profiles, and it has a spider, pythonscraping.py, and I've written a few things in here. Really just start URL is going to be that profile.php page that says, "Hey, welcome to the website." And then we're just parsing. The only parse function is just get the body text, so pretty straightforward. So we're missing something in the middle. How do we set these cookies? There are a few ways to do this, but the way I like to do it is to modify the ScrapePie request out to the website before that request object actually gets sent. And a good way to do this is to override the make requests from URL function. So this is an internal sort of ScrapePie method that's used by scrapepie.spider. And what we want to do is call the parent, so Python scraping spider, self, make requests from URL. And so this is going to get our request here. This is sort of like intercepting it in the middle of ScrapePie doing its thing. And all we want to do is add our cookie there. So cookies, username equals Ryan. Let's make this a little more exciting even, Ryan and then request.cookies, logged in. This is what lets the server know we're logged in equals 1, yes, I am logged in. Return requests, we need to make sure we return that. So we're getting this request from the parent, make requests from URL function, we're sort of intercepting it, adding our cookies and then returning it. We can run this in the usual way, scrapepie run spider python scraping.py, and great. Remember in chapter 3, when we looked for Dunkin' Donuts locations, but they were tricky to find because they were loaded dynamically on the page? Well, there are multiple approaches to this kind of a problem as it turns out. Personally, my favorite is just to look for the hidden API requests, just like we did in chapter 3, find the original source of the data and then use that API request in your scraper. But now we're going to do something which is not quite as slick or elegant, but way more impressive looking. It's actually a really useful tool to use in a variety of situations. So that's right, we're going to bring out the big guns, the Moab, that is the mother of all bots, of course. And we're talking browser automation. To do this, we're going to need to grab a couple of things. So first, install a library called scrapepie Selenium. This is a Python package that installs a browser automation tool called Selenium. And this allows you to use it smoothly with scrapepie. Next, you're going to need to grab a file called a browser driver. This driver file acts as an interface between the code and Selenium and your actual web browser software, allowing Selenium to drive the browser. Obviously, this Chrome driver file is only going to work with Google Chrome. If you don't have Google Chrome, I do recommend you try it. There's also a WebDriver for Firefox that you can get. The Selenium, indistinct, approximately the same for both, but in my experience, Chrome driver is better maintained and less buggy than Firefox, especially in recent years. So once this file has been downloaded and unzipped, make sure to move it somewhere memorable because we're going to need to let our scrapepie project know where it is in the settings file. So the entire chain looks like this. Your scrapepie code interacts with the scrapepie Selenium library, which interacts with Selenium, which knows where the driver file is. The driver file drives your web browser. And if this looks complicated, don't worry about it too much. It really just boils down to a few lines of configuration and a couple of lines of scrapepie. So let's go over it. Alright, I've conveniently made a new scrapepie project called Locations with the Dunkin' Donuts scraper in it. So, here are the 3 lines we'll need to add to settings.py, up at the top here. So there's the Selenium driver name, which is going to be Chrome. You want to let it know where it is. Absolute paths tend to work a little bit better. And then an empty array for the Selenium driver arguments. If you want to use headless browser mode, which is where the browser doesn't actually physically pop up on your screen, but sort of runs in the background, just uncomment that line. You'll also want to add some middlewares. Alright. So there's the Scrapy Selenium middleware that we need to import there. Okay, so now for the actual spider. We're going to import the Scrapy Selenium package from Scrapy Selenium, import Selenium request. Alright. Next, we're going to make use of that make requests from URL function that we discussed in the last section. And what we're going to do is we're going to have it return a Selenium request object. Alright, so we need to make sure this has self and URL in the arguments. And URL equals URL. We also need to provide a wait time, wait_time. So, this is a maximum wait time in seconds that Selenium will wait for the page to load before timing out. And this goes hand in hand with wait until. Now this whole Selenium wait feature is really powerful. And honestly, we could do a whole chapter just on this, but for now, let's just wait a second. So let's just define a quick and dirty function up here. It's going to take in a Selenium driver object, and it's literally just going to do a time.sleep 1 second and then return true. And this is kind of a nice little hack for situations like this when you don't want to do a lot of examination of the page, or maybe you don't know quite what you're waiting for yet, and you just want to wait for some set period of time. Alright. Now the parse function is written just as if all those dynamic elements are on the page. It's none the wiser, it's going to get its Selenium request object, and it doesn't really have to worry about anything. And we can actually just run this now with Scrapy run spider duncan.py. Before we do that, I'm going to minimize the page. And you can see the browser literally popped up. And if we look for the addresses, you can see them right there. The page loaded, the dynamic content loaded, and our scraper was able to actually pick up those addresses on the page. Okay, this section's a fun one. We're going to sort of tie everything all together in Chapter 4 and show you a delightfully redundant way to log into websites without messing around with cookies and all of that. You just type your information in and press the login button, of course. Remember, on this website the username can be anything and then the password has to be password. Great. So we're going to start this off with a brand new profiles project. And this project has a spider called pythonscraper.py. The start URL is going to be the same as the one we used in the first section of Chapter 4. So that's that login page that we just saw. We also want to make that same make requests from URL function that we used in the second section. And that's going to return a Selenium request object. Also note that we want to bring over the same settings.py file we set up in the last section. So now let's go to the really fun part. Now let's write the parsing function, but this time it's not really a parsing function. There's actually a lot of sort of action stuff we have to do in here. What we're going to need to do is find this username field element, enter some texts into it, then find the password field element, enter some texts into it. Then find the button element and then click it. And then we'll have to find this profiling, click on that. And then we'll grab the text from the profile page. Alright, so let's break it down. The first thing we need to do that is a Python object. This is a Python Selenium object called a driver. This is not the same as the Chrome driver file that you downloaded. It's sort of the code representation of it in the Python Slimming package. And this driver is going to be nested in our Selenium request object. So that's going to be the response object that gets passed into this parse function. So we're going to be able to find that at response.request.metadriver. And yes, I did have to consult the documentation for this one. It's a little bit arbitrary, but that's where that Selenium driver object is. And this driver has some cool stuff I can do, like driver.findElement by XPath. Okay, so this is a Selenium function, findElement by XPath. And what it does is get an element from the DOM that we can use to interact with this element on the page. And if you look at the page, the first element we want is that username field. So that's input name equals username. Okay, great. Alright, so we're going to extract the username object into the variable username, and then we're going to want to use another Selenium function called semKeys. So username.sendKeys, and we send the username that we want to log in with. Then we're going to do the same thing with the password field. So we can really just copy-paste. Instead of the name being username, it's going to be password, of course. And let's send the keys password. Then we want to find the submit button. So that's submit driver.findElement by XPath. And that would be input type equals submit. Great, and then we want to do submit.click and oops. Make sure those variables are unique. I think that would technically work, but let's make this code a little bit clearer there. Alright. And then we want to wait a second or two. Let's have a little fun with it. And then we want to find the profile link on the page. So we should be logged in now. We should have those cookies set in the browser. So let's find the profile link, and that's at driver.findElement by XPath, of course. That's going to be that a ref equals profile.php. Great. And then profile link.click. Wait a couple of seconds for the next page to load, and now we should be on the profile page itself. So from there now we're back in ScrapeEye land. We just returned text response.xpath. Note that we're using that ScrapeEye response again. And this is all back in ScrapeEye land text.get. Okay, so this is all Selenium using the driver. This is ScrapeEye using that response object. And we can just run this in the usual way. ScrapeEye run spider python scraper.py. I'm going to tile the browser again. And the page opens. We enter the text, log into the website, click the profile, and then great. Our scrapers should have grabbed that text. So that's just a quick sample of some of the cool interactions you can do with Selenium and ScrapeEye. So the thing that I recommend to everyone when pursuing any programming or computer science field, pick a project that interests you and learn via doing that. Granted, if you're watching this series because you already have a specific project for work, well, great. Maybe you declare your interest to be making money and pursue that. But seriously, having a specific goal you're working towards is going to make the path to learning so much easier. More concretely, I think there are a few major directions that most people are going to want to go in from here. If you're interested in Selenium and automated testing with Selenium, check out Python Automation and Testing by Bhumika Agarwal. This covers Selenium from a web application testing point of view, but the principles can also be applied to web scraping. So the only difference is you're not testing an app you own, and web scraping, you're testing someone else's app, right? You might also be interested in data science, so, doing stuff with your scraped data. Now, as it turns out, data science is not quite as glamorous as Wired magazine articles would have you believe. A lot of people struggle with just keeping their data organized and forming proper relational data structures, so, might I point you to MySQL? I love planning and setting up a solid database before any large scraping project, and Bill Weinman has a fantastic introductory course called MySQL Essential Training. MySQL works really well with Python, it's well supported, free, really a go-to part of my web scraping stack. If you want to work more with in-memory data structure manipulation or data cleaning, sort of actively working with the data and get to know a few popular Python libraries while you're doing that, check out Python Data Analysis.